I'm the CEO of CA Fatigue Limited. My background is fatigue, dynamics and FEA. Around 4 or 5 years ago, I became very frustrated by the limitations that existed. And so I decided to form my own company, CA Fatigue Limited, and go about pushing out the technology in a more user-friendly way. So what we've put into Nastran Embedded Vibration Fatigue is really the fruits of that effort. I'm trying to actually take the technology and make it more accessible, more easy to use, and more flexible in its implementation. We actually worked with the Nastran development team to put the hooks in, the connections, right at the heart of the stress recovery stage of Nastran. So it is truly embedded. It's not connected, and we're just saying it's embedded. It is properly embedded. And that's why it works so well. That's why it's so powerful, and we're getting these huge performance benefits out of the combined product. The Nastran is a tool that generates stresses. It can generate stresses for very complicated engineering situations where you have all sorts of interesting resonances, dynamic behavior, complicated loads. Nastran will give you the stress information you need for that. What our technology will do, it will take that information, that stress data, and further process it into advanced response statistics, fatigue results, damage calculations, all sorts of additional information that a typical user would want. But why is that such a big deal? It's because the user sometimes doesn't want stresses. He wants fatigue life information, durability information, maximum peak results. And we can get those results from the stresses, but we can get them in such a way that the user doesn't have to write the stresses onto a disk. Now, that might not seem like a very big deal, but if you're dealing with a large car vehicle, for example, the stress file that's created in analysing that car could easily be 3,000, 4,000, 5,000 gigabytes of stress. So these stress files become so large that you really can't handle them anymore. So once you've generated the stresses inside Nastran, we use them in small quantities. Once we've, if you like, filtered them or decomposed them down into a smaller subset, we discard the original stresses and then proceed to pick up the next set of stresses. So by doing this, we don't need to generate these large files. So you can go ahead and take your large car vehicle, which would make a 3,000 gigabyte stress file, and we only ever need to perhaps have 30 or 50 of those gigabytes in memory at any one time. Sometimes the user wants to put a base shake into a system, and on top of it he wants to do a sine sweep. That's a typical test specification that he might want to apply. In the past you couldn't do that in the analysis environment. But our technology now allows you to mix those two things together and generate the responses, the fatigue life result, the damage calculation, the maximum peak response. So if you're designing a satellite, we can tell you how much the satellite's going to displace. We can tell you what the acceleration levels are going to be at certain parts. If the satellite's made up of different parts, for example, you're looking at a prism inside a satellite system, the prism will be held in place with a frame. We can tell you how the prism's going to vibrate. We can tell you how the frame that's holding it will vibrate. And most important, and this is unique to what we do, we can tell you whether that prism and the frame are going to hit. So you can apply your complex dynamic loading, and we can work out probabilistically whether or not those two parts are likely to collide. That's an application for satellites. Similar application for automotive would be car headlamp. If you're designing that, you want to know whether the inner part of the headlamp is going to touch the casing when you're driving along the road. You may want to know that because it would break if it touches, or you might want to know if it's going to touch because that will cause a noise, and you may not want that noise. So an interesting question is, who are the typical users that might find this technology helpful? Well, it's anyone where dynamic behavior may or may not be part of what they're involved in. It's hard to come up with a mechanical engineering system where dynamic response isn't at least likely. So the answer is it's nearly every system. Very few systems actually can be can be described as purely statically responsive. So what we can do for that kind of user is give them a very user-friendly way to do their fatigue calculation, their response calculation directly inside Nastran. So they don't need to do Nastran and then send the file somewhere else and then post-process it with another tool. Nastran will have an output request that directly gives them the fatigue life results or the random response variable they want, displacement, velocity, acceleration, and then they can take those and generate all sorts of data that they want inside Nastran. How will Nastran embedded vibration fatigue change the way customers work? On the one hand, they're currently limited in terms of the size of model they can process. So they have to make compromises, and they won't need to do that anymore. They can generate the results for their full vehicle. So there'll be a tremendous possibility for a reduction in the number of things that have to be done at the same time. The second area where I think it's going to help them is they currently have to make compromises related to what they do. They've not been able to apply complicated loading conditions like sine sweeps on random before. So they've had to simplify that down and apply a simplified profile and then decide for themselves whether the simple profile does the analysis or checks the criterion correctly for them. They can apply the real loads, the real mixed complicated loads inside this process and get realistic response results for those kinds of loadings. So they're going to be able to do things on bigger models, they're going to be able to do multiple things at the same time, and they're going to be able to get better quality of results out of the process at the end.